Good afternoon, everyone. My name is Amit. I am working in as an information technology department as an assistant professor. Today, I am representing Introduction to Normalization, which is comes under database management system. So, at first, we have to know what is normalization. Normalization is a procedure by which we can analyze a given relation schema by applying such functional dependencies and keys to get the smaller forms. It will minimize the data redundancy, which means the repetition of data, and also we can remove the update anomalies, means insertion anomaly, deletion anomaly, and modification anomalies. Normalization is a procedure by which we can convert the table from lower normal form to upper normal form. It also gives us the it also removes the space complexity. We have to know about the repeating group. A repeating group is a set of attributes in a relation that occurs with multiple values in a single occurrence of key attribute. Unnormalized form is the kind of relation which contain different kinds of anomalies and also repeating groups. For this particular example, we have seen that part number and part name are the repeating group. So we have to remove it. So we convert this table to first normal form, which will contain part number and part name in different row. Next, prime attribute. Prime attribute are the attributes in a relation which is depend on the candidate key of that relation R. Non-prime attribute are the set of attributes of the relation R which is not dependent on the candidate key of the relation R. There are a lot of advantages of normalization. It minimizes redundancy of data. It automatically minimizes the insertion anomaly, deletion anomaly, and updation anomalies. It can be used for security mechanism. The main motto of the normalization to get the higher normal form from the lower normal form, and the higher normal form obviously is the updated one from the previous one. Some views can be used for data manipulation. Some views which is where the data manipulation can occur is known as updatable view. Some view which are where data manipulation cannot be done are known as non-updatable view. Now there are different types of normalization. First is first normal form, that is 1NF. Then second normal form, that is 2NF. Then third normal form, 3NF. BCNF, Boyce-Codd normal form, 4NF, and 5NF. So at first we will discuss about first normal form. A relation schema R is said to be first normal form if there is no composite attribute. This is point number 1. Point number 2, if there is no multi-valued attribute. Point number 3, if there are no combination of multi-valued attribute and composite attribute. So the attribute value permitted by 1NF must be a single atomic value. So steps to convert from unnormalized form to first normal form, we have to remove the outermost repeating group and create a new relation, and also we have to find out the primary key of the table by which we can uniquely identify the row. So it is a example where I can show you that this is the unnormalized form which consists of repeating group C1 and C2, and after applying the first normal form, which every attribute must contain the atomic value. So C1 and C2 are totally different into different rows. Next comes to 2NF, second normal form. A relation schema is said to be 2NF if it is in 1NF and also every non-prime attribute of relation R are totally functionally dependent on the primary key. This is the main logic of under this second normal form. So 1NF plus non-prime attribute must be fully functionally dependent on the primary key. So what are the procedures to convert from 1NF to 2NF? At first we will remove the attribute that are partially functionally dependent on the primary key. We have to remove that one. So we will take an example. Here R is the relation. It consists of A, B, C, D, E, F. These are the attributes, and the following function dependencies are A, B implies C, A implies D, B implies E, F. Here A, B implies C, where A, B is the prime attribute or the primary key, and C is the non-prime attribute. So, but the other function dependencies like A imply D and B imply EF, these are partially dependency. So we have to break it down into three relations by which we can get the second normal form. So first one is relation 1, that is consists of attribute A and D, where function dependency are A imply D, where A is the primary key and D is the non-prime attribute. Second relation is R2 BEF. So B imply EF, B is the primary key, and E and F are the non-prime attributes. The third relation is consists of ABC, where AB implies C, where here AB is the primary key and C is non-prime attributes. Next comes to third normal form. A relational schema is in 3NF if it is in 2NF plus and also every non-prime attribute of R, of relation R, is non-transitively functionally dependent on the primary key of that relation R. So it must be on 2NF plus every non-prime attribute of relation R is non-transitively functionally dependent of the primary key of the R. So we will take an example for this kind of schema supplier table. We have different attributes. So S number, S name, CT, status, project number, and quantity. These are the attributes. So there are 6 attributes are there under the supplier table, and we have the following FDs: S number to S name, S number to CT, CT to status, and S number, P number are the repeating group imply quantity. So we have to normalize this table to 3NF. So at first we have to find out what is primary key. Our primary key is S number. By using the serial number, supplier number, we can face the table uniquely. So S number is the key. S number is the primary key of the supplier table. It contains a repeating group, that is project number and quantity. So this table is not in 1NF, it is in UNF form, unnormalized form. So we have to decompose into the two schemas to get the 1NF. So we convert this table, supplier table, into two following tables, supplier 1 and supplier 2, to get the 1NF. So in supplier 1 we took 4 attributes are there: serial number, serial name, city, and status. So serial number or supplier number, by using this attribute we can get the supplier name, by using supplier number we get the city, and by using the city we get the status. So these are the following FDs. So in supplier 1, supplier number, supplier name, city, and status attributes are there. In supplier 2 attribute, we get supplier number, project number, and quantity. So by using supplier number and project number prime attribute, we can get the quantity. So this is another table. So this is the previous tables, supplier 1 and supplier 2 are in 1NF. Now this table we have to convert in 2NF. So for 2NF, the relation schema supplier 2, it is already in 2NF because the non-prime attribute quantity is fully functionally dependent on the supplier number and project number. However, supplier 1 schema, that is also in 2NF because of the following reason. What are the reasons? It is clearly shown that supplier number to supplier name we will get it. So non-prime attribute supplier name is fully functionally dependent on the key supplier number, and also supply number to city. So non-prime attribute city is fully functionally dependent on the key supply number. From supply number to city and city to status. So here we get supply number to status by using the transitive dependencies. By using transitive dependency. Hence, the non-prime attribute status is fully functionally dependent on the S number, supply number. So these following tables are in 2NF. Now, our motto is we have to convert it to 3NF. The schema supplied to is in 3NF because supply number and project number to quantity holds a non-trivial functional dependency, and supply number and project number are the key of supplier 2. But schema supplier 1 is not in 3NF, so we have to convert it because CT to status neither be CT is a primary key or status will be a prime attribute. So we have to decompose by the two following schemas. Supplier 1A. So where we convert supplier 1 table to supplier 1 and supplier 1A and supplier 1B table. So in supplier 1A table, supplier numbers, the supplier name and city is there, and the following FDs are supplier number to supplier name, supplier number to city. And in case of supplier 1B, we will get city and status. So FD will be city to status. Thus, we normalize supplier schema up to 3NF. We get the following three schemas. What are that? Supplier 1A means is supplier number, supplier name, and city. And the following FDs are supplier number to supplier name, supplier number to city. In case of supplier 1B, city and status. So following FD will be city imply status. In case of supplier 2, supplier number, project number. Now another important normalization form is BCNF, which stands for Boycott normal form. A relational schema R is said to be BCNF if all the determinants are the candidate key. BCNF, a table is in BCNF which must be 3NF, but a table is in 3NF may not be BCNF. Here is an example, a table named student which consists of 4 attributes: student, course, email ID and marks. So here some possible candidate keys are student ID and course ID, and also course ID and email ID, which are overlapping between each other. So we get the functional dependencies in this following student table are from student to email ID. So by using the student ID, we can get the email ID of the students. By using the email ID, we can get the student details, and by using the student ID and course ID, we can get the rest of the attributes, and also by using the course ID and email ID, we can get the rest of the attributes of the student table. Here, student ID and course ID and also course ID and email ID are the determinants and also the candidate keys. But student ID and email ID are the determinants but not the candidate keys. So this table is not in BCNF. So we have to convert it in BCNF. So to convert the table to BCNF, we have to break the table in the two following table, and we have two cases. The left one is case 1 and the right one is case 2. Under the case 1, we have two tables. Table number 1, student 1, which consists of student ID, course ID and marks, and table 2 is student 2, which consists student ID and email ID. In student 1, we have student ID, course ID and marks. So by using the details of student ID and course ID, we can generate the marks of a student, and also by using the student ID, we can get the email ID of all the students. This is case 1, and another case 2 is course email ID and marks. So by course ID and email ID, we can get the marks of the students, and also by using the email ID, we can also get the name list of the students. So these two cases both are in BCNF. So student 1 and student 2 table are in BCNF. So this is all about normalization. Thank you very much.